In question 3, we're supposed to use synthetic substitution to evaluate the given polynomial. Synthetic substitution is another name for our synthetic division, but it really keys in on one special idea, is that when we look at our remainder, the remainder will equal this function evaluated at -2. So it gives us an alternative to evaluating the function without the plug and chug method. So I'm going to illustrate both methods here. What I want to do is I want to grab all my coefficients out of the equation, which I need a 1 for the x to the 4th. There are no x cubes. There's a -5x squared. There's a 2 for the x's and a -10 for the constants. The remainder that I get right here will be equal to the function evaluated at -2. So this was an alternative, and a rather easy alternative to evaluating a function. So I bring down the 1, -2 times 1 is a -2. Add them together, it's a -2. -2 times -2 is a +4. Add them together, it's a -1. -2 times -1 is a +2. Add them together, it's a 4. -2 times 4 is a -8. Add them together, it's a -18. This -18 represents the value that you would get if you put in a -2 into the function and plugged and chugged. So I should get the exact same answer if I put in a -2 in for all those locations of x. Raised to the 4th, minus 5, -2 raised to the 2nd, plus 2 times a -2, minus 10. I should get the exact same answer, -18. Like I said, this is just an alternative method. -2 to the 4th is 16, and then it's a -5 times -2 squared is 4, and then it's +2 times -2, which is a -4, minus 10. A little bit more simplifying, so we got a 16 minus 20, and this is minus 14. So we have a -34, so it's 16 minus 34, and 16 minus 34 is a -18. Now this remainder that we found up here, -18, represents the output when you put in a -2 into the function f of -2. So as I repeat, it's an alternative to the plug and chug method. The directions specifically tell you to use the synthetic substitution, and exhibit that you know how to use this method and what it represents. This remainder is the value of your function when evaluated at a -2.